Hello there, Mr. Sutton here, bringing you the Algebra 2 6-6 Part 1 homework solutions on exponential and logarithmic equations. In this one, we will be focusing on the exponential equations. On this first problem, I noticed that I have the same base on each side, so I can actually very quickly just cancel out those common bases and write 3x plus 5 equals 1 minus x. Just set the exponents equal to each other. And now let me just solve for x. If I add x over to the left, that'll be 4x over there. Subtracting 5 over to the right gives me negative 4. And then dividing both sides by 4, we have x equals negative 1. For this problem, they're trying to have us solve this equation, 3 to the x equals 7. Looking at common bases, there is no common base for 3 and 7. So we're going to go straight to logarithms. I'll take the log of each side. So using my pop-out rule, that gives me x log of 3 on the left side and log of 7 on the right side. And to get x by itself, I just have to divide both sides by log of 3. So we have a log of 7 over log of 3, which I'll go ahead and plug in the calculator. So let's see here. Do a fraction. We've got log of 7 over log of 3, and that comes out to about 1.771. On this problem, trying to solve the equation, I've got 7 to a power over here, and I've got 60 over there. Let me first divide both sides by 5 and see what we're dealing with. So 60 over 5 gives us 12. Since there is no common base for 7 and 12, those aren't both powers of the same number, at least not an easy number, I'm going to take the log of both sides. Using my pop-out rule, that's going to give me 5x log of 7 on the left and log of 12 on the right side. And then to get x by itself, I have to divide by 5 and log of 7. So this is going to end up being log of 12 over 5 log 7. Let me go to Desmos for that. So I'm going to use my fraction notation here. So we've got log of 12. And then I'm going to make sure that 5 and log 7 are both in the denominator. Now, if I didn't have this fancy sort of fraction mode, I would need a parentheses around the 5 and the 7. But since I do, it takes care of the PEMDAS for me. And that comes out to about 0.255. For this problem, trying to solve this exponential equation, I see that 5 and 25 are both powers of 5, so I can use the common base method on this one if I want. I'm going to rewrite 25 as 5 squared. And then using my exponent rules to simplify that, multiplying the exponents together here, we end up with 5 to the 2x minus 10. Now that I have the same exact base, I can cancel out my bases and write x minus 3 equals 2x minus 10. And now just solving this normally, if I subtract 2x over to the left side, that gives me a negative x over there. Adding 3 over to the right gives me negative 7. And then dividing by negative 1, we get a final answer of x equals 7. This problem, I noticed that 512 and 1 over 8 are both going to be, they have a common base to them. Now there's a few options I have for the common base. If I wanted, I could make these both powers of 2, but I think it'd be easier if I can have a bigger base. Is 512 a power of 8? Well, let me find out. So let me do 8 to the, let's see, second is 64, 8 to the third is, there it is, 512. So I'm going to rewrite 512 as 8 to the third. And I'm going to rewrite 1 over 8 as 8 to the negative 1. Now let me go ahead and multiply my exponents to simplify things a bit. So over on the left, I've got 8 to the 15x minus 3, because I have to distribute that 3. And on the right, this is going to be 8 to the positive 4 plus x. Now that I have the same base, I can cancel out those 8's, leaving me with just 15x minus 3 equals 4 plus x. Subtracting x over to the left side, that's going to be, let's see, 14x over there. And adding 3 over here gives me 7. If I divide by 14, I have 7 over 14, which I can reduce to 1/2. For this problem, before I try anything else, I'm going to at least try to isolate this exponential term. So I'm going to subtract the 9. That gives me a 6 over there. And then divide by 3 to get a 2. Since e and 2 don't have a common base really, I'm just going to use logarithms on this one. Since I'm dealing with e specifically, I'm going to use ln, natural log. So using my pop-out rule, I'm going to end up with 4x times the ln of e on the left side and ln of 2 on the right side. Now to get x by itself, I have to divide by 4 and the ln of e. ln of e is just 1 though, so I can just kind of forget about that. That's actually why I like to use ln when there's an e involved. So I'm really just doing ln of 2 divided by this 4, which I'm going to go ahead and do on the calculator. So here we go. Let's do a fraction with an ln of 2 over 4, and that comes out to about 0.172. For this problem, which is in the honors only set for this homework, we're told that the length of a scalloped hammerhead shark, whatever that is, can be modeled by this function below. And t is the age of the shark. We want to know how old's a shark that's 175 centimeters long. So this actually might be an interesting question to ask. If we're doing 175 centimeters, that means we're replacing L right here with 175. And now we're going to just try to isolate this exponential term so I can solve this exponential equation. So we have 175 minus 266. Let me go to the calculator. I'm going to have to go there later anyway. So 175 minus 266 is negative 91. And now I'm going to divide both sides by negative 219 to get e by itself. So that's just going to be 91 over 219. I could reduce it further, maybe, possibly, but it doesn't matter because I'm going to plug it in the calculator anyway. And now to get this t out of exponent land, I need to take the ln of both sides, or any log will work, but ln works best with e. So I'm going to have ln of this fraction equals negative 0.05t times the ln of e. Now the nice thing about ln of e is that's just 1. So to get t by itself, I really just need to divide by negative 0.05. And I'm going to plug this big mess of stuff into my calculator now. So let me clear that out. Let me do a fraction, and I have ln and then parentheses with another fraction. Inside there we got 91 over 219, and let me close that. Let me go down to the denominator, and now we have negative 0.05 for a grand total of about 17.56, so about 17.6 years for the age of that shark. On this one, let's say that we are driving home on a hot day when the car overheats and stops running. It overheats at 280 degrees Fahrenheit and can be driven again at 230. We want to know when it is 80 degrees Fahrenheit outside, and the cooling rate of the car is this 0.0058, which doesn't sound very fast. How long do we have to wait until we can continue driving? So there's a whole bunch of things to plug into this formula here. This is our Newton's law of cooling formula. We're just going to go left to right. So this t right here with no subscript, that is the target value of the thing that's cooling down. So we want it to be 230 degrees. So we'll put 230 in for t there. T0, this is the initial temperature. So if it's overheated, that means it's at 280 degrees. So we've got 280 for T0. TR is the temperature of the surrounding area, which is the 80 degree outside temperature. So that's minus 80 in there. And then we've got e to the negative. They gave r to us, 0.0058. And t is what we're actually solving for because they're asking how long. So we have e to the negative 0.0058 t plus that outside temperature of 80. All right, so let's go through and solve for t now, that little t hidden in there. So I can subtract 80 from both sides. That gives me 150 over on the left side. And then 280 minus 80 here is going to give me 200. And I guess I'll subtract 80 afterwards. Now we've got 150. So we subtracted 80. We did 280 minus 80. Here's where we stand on our equation. Next, we're going to divide by 200 so we can isolate that exponential term. So that's 150 over 200. I could reduce that to 3/4 or 0.75 if I wanted to. And then to get rid of the e, I'm going to take the log of both sides. I'm going to use ln because it works better with e. So I'll have ln of 0.75 equals negative 0.0058t times the ln of e. ln of e is just 1, So when I get t by itself, I really just have to divide by this negative 0.0058. And at this point, I really need to use the calculator to see what that is. So plugging that in, we had, let's see here, fraction, ln of 0.75 divided by negative 0.0058 comes out to about 49.6. So in 49.6 minutes, it will again be safe to drive your car.